Welcome back, everybody. This is our sixth session in JEE mains previous year questions for chapter Ray Optics and Optical Instruments. Before this video, we have made 5 videos in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous years. So if some of your friends are preparing for NEET, you can guide them through those videos. And if you find these videos useful, helpful, then do press the like button, share them, and subscribe to our channel. Also, if you like to support us financially, you can scan these QR codes and make any amount of donation you want. Any amount will be highly appreciated. With this, let's start today's video. In the previous one, we covered up to, I think, here 31, 32. Yes, this is covered. This yes, so we covered up to 45 in the previous one, and today we will start with 46. So formation of a real image using bioconvex lens is shown below. If the whole setup is immersed in water without disturbing the object and the screen position, what will one observe on the screen? So we know that from the lens maker's formula that focal length of a lens is equal to mu of the lens material by the mu of the outside material minus 1 into 1 by r1 minus 1 by r2. Now, when this whole setup is in air, so for air, mu o or mu of the outside world is equal to 1. And we have some fixed value of the focal length. Now, what happens when we equate, or when we can say immerse this whole setup inside the some liquid? Then what happens that mu o becomes greater than 1, because for any body, any medium, refractive index is always greater than 1. So this term, if mu o is greater than 1, then this term is decreases, this term decreases, and if this term decreases, then what will happen, that focal length will increase. So initially light was getting focused here, now light will be getting focused, like let us say at some this point here. And if light is getting focused behind the screen, so what will happen here now, that uh, the image will not be formed on the screen. So we can say image disappears. That is option A here. Let us move ahead. So a plano-convex lens, focal length f2, refractive index mu2, and radius of curvature r fits exactly into a plane concave lens, focal length f1, the refractive index mu1, radius of curvature r. Their plane surfaces are parallel to each other, then the focal length of the combination will be. So first we have a plano-convex lens. So this is a plano-convex lens, and we have another, we can say, plano-concave lens. So plano-concave lens will be like this. Now this is a plano-concave lens. Now it is mentioned that both of these have different refractive indexes. Now if they had the same refractive index, then if we join them, then it will look like this. If we join them, system will look like this. And if they had same refractive index, then this boundary does not matter, and this will act as a normal plain glass slab, so it will not focus light. But as they have different refractive index, so it will be still functioning as a lens, and it will be still focusing light. So what we can do here, we have to calculate their individual focal lengths, and then we will use a formula that 1 by f is equal to 1 by f1 plus 1 by f2, and these can be calculated using lens maker's formula. So 1 by f1 for this one will be equal to mu1 minus 1 into 1 by infinite for this side, and 1 by negative of r for this side. This will give us mu minus 1 by r. Now for f2, for this one, 1 by f2 will be equal to mu2 minus 1. For this, we have negative radius of curvature, so that will be negative 1 by r minus 1 by infinite. So this will give us minus of mu2 minus 1 by r. Now, if we add both of these, we will get 1 by f is equal to mu1 minus 1 by r minus mu2 minus 1 by r. And from this, we will get 1 by f is equal to mu1 minus mu2 by r. And from that, f is equal to mu1 minus mu2 by r. Now our answer, it should be inverse, so it will be r by mu1 minus mu2. So our answer matches approximately with this one, but we have negatives here, negative sign problem that can be easily encountered. And uh, and what we have to do for that, we have to fit them like this. If we fit them like this, and this is our first lens and this is our second lens. If we fit them like this, then we will get the option B as answer. So here option B is the right answer. Now let us move ahead to the second one, or next one, sorry. Object is at a distance of 20 meter from a convex lens of focal length 0.3 meter. The lens forms an image of the object. If object moves away from the lens at the speed of 5 meter per second, the speed of the direction of the image will be. So we know, using the lens formula, that 1 by v minus 1 by u is equal to 1 by f. If we derivate it with respect to time, so what we will get, minus of 1 by v square into dv by dt. Here we will get plus 1 by u square of du by dt is equal to 0, because focal length is constant. And from this we can write that dv by dt is equal to v square by u square into du by dt. Now this is image speed. This is basically v by u square, or magnification square. So this is magnification square, and this is object speed. So image speed is equal to m square times object speed. Now we have to first calculate the magnification. So for lens magnification is v by u, and that will be equal to uh, we have to calculate first v, I think. Yes, we have to calculate the v. So for that, we will use the same formula, that 1 by v will be equal to 1 by f plus 1 by u. That will give us 1 by 30, that is focal length 0.3 meter, and u is going to be negative, so here we will get 20. And from this, it is in meters, both are in meter, so we will take it as it is. We will take it as 0.3, and that will become 10 by 3. Now if we solve this, and then from that we will get v is equal to 60 by 197 meter, and then magnification will become 60 by 197 into u, that is 20, so that magnification is 3 by 197. So now image speed will be m square times, means 3 by 197 square, into object speed, and object speed is 5 meter per second. So if we solve this, we will get 1.16 into 10 raised to power minus 3. Now we have taken object speed as positive. Now if we see that object is moving away from the lens, so suppose this is lens, so object is moving like this, and we have taken this direction is positive, and our answer for the image is also positive. So image speed of the image will be in this direction. So here our image will be coming towards the lens, and object will be going away from the lens, and that is mentioned in option D, that towards the lens. Now let us move ahead. A plano-convex lens of refractive index mu1 and focal length f1 is kept in contact with another plano-convex lens of mu2 focal length f2. If radius of curvature of these sphericals is r and f1 is twice of f2, then mu1 and mu2 are related as. So we have to find out relation between mu and mu2. So let us start with the plano-convex lens. Suppose this is our plano-convex lens. For this, we have 1 by f1 is equal to mu1 minus 1 into 1 by infinite into minus of 1 by negative of r. And so this will give us mu minus 1 by r. Now for the second one, which is plano-concave lens. So suppose this is the plano-concave lens. And it is plano-concave, so let's take planar side first so that symmetry is retained. So for this, 1 by f2 will be equal to mu2 minus 1, 1 by infinite minus 1 by r. So this will give us negative of mu2 minus 1 by r. Now as mentioned, that ratio of their focal lengths or f1 is equal to twice of f2. Now it is only possible if we take the magnitude. So magnitude wise, we will have f1 is equal to twice of f2. Now magnitude of f1 will be r by mu1 minus 1 and twice magnitude wise f2 will be r by mu2 minus 1. So r get cancelled and we get mu2 minus 1 is equal to twice of mu1 minus 2. And from this we have to find out the relation. So we can write minus 1 plus 2 is equal to twice of mu1 minus mu2. So twice of mu1 minus mu2 is equal to 1, and that is option B for us. So option B will be the right answer. Now let us move ahead. The eye can be regarded as a single refracting surface. The radius of curvature of this surface is equal to corona, that is 7.8 millimeter. The surface separates two media of refractive indexes 1 and 1.34. Calculate the distance from the refracting surfaces at which parallel beam of light will come to the focus. Now what is happening here? Suppose we have eye, and I am drawing a normal diagram. Means we have this is suppose our eye, and this is the inside part of eye where refractive index is 1.34 here mu, and outside of the eye mu is equal to 1, that is basically air. Now suppose some light is entering through this region, some light is entering through like this, and it is getting focus at the retina here. Now we can think that we can simply apply the formula that 1 by f is equal to mu minus 1 by 1 by r1 minus 1 by r2. Or we can also think that we can apply here mu of the, we can say if it is mu2 and this is mu1, then we can apply mu2 by mu1 minus 1 into 1 by r1 by r2. So both of these formulas will not be applicable here. And what is the reason? Because here the light after getting focus is into the same medium. It is not leaving the medium. These formulas are applicable when it leaves the medium, because normally we have a lens here, so it light enters the lens medium and then came back to the original medium from which it entered the lens. Here it enters the lens and stays into the same medium, so we have to use refractive surfaces formula, and that is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. So mu2 is here 1.34. Light is coming from the infinite. Oh, sorry, coming from the infinite. So we have to calculate v as it is. Now mu1 is 1. Light is coming from the infinite, and this will give us 0.34. And radius of curvature is mentioned, that is 7.8 into 10 raised to power minus 3. So when we solve this, we will get v is equal to 3.01 into 10 raised to power minus 2 meter, and that is basically 3.01 centimeter, and that matches with here. The nearest match will be option D. So option D is the right answer for this one. Now let us move ahead. A convex lens is put 10 centimeter from a light source and it makes sharp image on a screen kept 10 centimeter from the lens. Now glass block of refractive index 1.5 of 1.5 centimeter thickness is placed in contact with the light source to get the sharp image. Again, the screen shifted by a distance d, then d is. So we have to find out that how much distance it have to be shifted. So here we have to use concept of apparent depth. Now what will happen? Suppose this is our lens and this is the principal axis here. Now suppose we add a we can say glass block. So suppose this is the glass block which we have added, and suppose here is our light source. So what will happen? That initially light was going like this. Initially light was going like this. Now what will happen now? That at this point, light has to bend. If I draw a normal here, light has to bend towards the normal. So light will bend slightly towards the normal, and then light will go like this. Means for a glass, oh sorry, for the lens, it will appear that light is coming from some point here, not from this point. So this is the shift here that is happening due to the apparent depth. So let's calculate the shift. So that shift, suppose that is delta x, that will be equal to the original length or your original distance minus d by mu, and that will be equal to the original depth of this glass slab is 1.5 minus 1.5 by mu, that is again 1.5. So this will give us 0.5, that is in centimeter. So 0.5 centimeter shift means this object has been shifted towards the lens by 0.5 centimeter. So actual value of u that was previously 10 centimeter now will be 10 minus 0.5. So that will be now 9.5 centimeter. So now we can calculate using lens formula that 1 by v will be equal to 1 by f plus 1 by u, and that will give us 1 by 5 negative sign 1 by 9.5, and f is in let me check the, yes, f is in, oh I forgot to calculate the f, and f is can be easily calculated as object distance. Initially before this glass slab, object distance was 10 centimeter and image distance was also 10 centimeter. So image and object are at same distance, means they are at 2f, and 2f is equal to 10. So from this f will be 5 centimeter, that is I'm using here 5 centimeter. So if we solve this, from this we will get v is equal to 10.55 centimeter, and it is positive. Initially it was 10, now it is 10.55 centimeter. So our screen has to be shifted backwards by 0.55 centimeter from the lens. So that is Option D, 0.55 centimeter away from the lens. Let us move to the next one. A plano-convex lens becomes an optical system of 28 centimeter focal length when its plane surface is silvered and illuminated with the left to the right as shown in the figure A. If the same lens is inserted silver on the curved surface and illuminated from the other side of figure B, it acts like an optical system of focal length 10 centimeter. Refractive index of the material of lens is. So for that, let us start with the first case. So for the first case, let us assume that focal length is f1. So 1 by f1 will be equal to 1 by f1 will be equal to twice the focal length of the lens plus 1 by focal length of this mirror. As this is plane mirror, so it will be infinite. So we can say 1 by f1 is equal to twice the 2 by the focal length of the lens. Now for the second system, what we have to do, we have to solve them separately, because here we have a concave mirror. This is our concave mirror, and this plus we have a here plano convex lens. So for plano convex lens, suppose its focal length is let us mark as fa, and its focal length is fb, and their combined focal length is f2. So first let us calculate f of a. So f of a from the lens maker formula, 1 by f of a will be equal to mu minus 1 into 1 by r minus 1 by infinite. So from this, f of a is equal to r by mu minus 1. And similarly for this part, let us also calculate. For that, f of l here will be 1 by f of l will be equal to mu minus 1 by r minus 1 by infinite. That will be same, 1 by fl will be equal to mu minus 1 by r. So this will be equal to twice of mu minus 1 by r. Now for the mirror, that is f of b, that will be equal to r by 2, where r is the radius of curvature. So now we add, as both of these are in contact, so 1 by f2 will be equal to 1 by f of a plus 1 by f of b, and that is equal to mu minus 1 by r plus 2 by r. And here we will get 2. Why? Because when light enters here, first it goes through the lens, then it gets reflected from the mirror, and then it again goes through the lens. So it is traveling light from the lens through 2 times. That's why we have to add 2 here. That's why we also added 2 here. And for the mirror we get this. Now if we solve this, we will get 2 by r as common, and mu minus 1 plus 1. So this is 2 mu by r. So now let us move ahead. So for first one, our f1 is 28 centimeter. So that is, I think, yes, here it is f1. So 1 by 28 is equal to twice of mu minus 1 by r, and f2 is 10 centimeter. So 1 by 10 is equal to twice of mu by r. Now we can divide both of these. So if we divide, we will get 1 by 28 divided by 1 by 10 will be equal to twice of mu minus 1 by r divided by twice of mu and r here. So mu gets 2 gets cancelled and r gets cancelled. Here we will get 5 and 14. So 5 by 14 is equal to mu minus 1 by mu. So 5 of mu is equal to 14 mu minus 14. 14 is equal to 9 mu, and mu will be equal to 14 by 9 here. And if we check 14 by 9, that is equal to around 1.55, and that is option B here. So let us move ahead. Now a convergent doublet is of separated lenses corrected for spherical aberration has resultant focal length of 10 cm. The separation between the two lenses is 2 cm. The focal length of the component lenses. Now for this combined system, we can write that 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 and f2. Now we will solve it for option A 1820, and from that we will get 1 by f is equal to 1 by 18 plus 1 by 20. Their separation is 2, and here 18 into 20. And if we solve this, then we are going to get 1 by f is equal to 1 by 18 plus 1 by 20, and from this we will get minus 1 by 180. And this can further solved as 180. This will give us 10, this will give us 9, this will give us 1. So this will be 18 by 180 or equal to 1 by 10. So f will be equal to 10 centimeter, and that is the required. So option A will be the right answer here. So with this, we end this video here. Hopefully whatever we have covered here is helpful to you. Again, if you find if you have any doubts or suggestion, you can put them in comment section. I will try to resolve them. And if you like these videos, then do like them, share them. And if you want to support us, you can scan these QR codes and donate any amount, whatever you want. With this, we end this video here, and we will meet in next video.